Hi, I'm Jen Leone. I'm the Chief Sustainability Officer at the New York City Department of Housing Preservation and Development, HPD. We are really excited to present our white paper today, Uncovering the True Cost of Passive House. And we will be discussing the performance of New York City's earliest adopters of multifamily and mostly affordable passive house projects. This has been a great collaborative effort with some of the folks who are deeply engaged with passive house at this scale, but I will allow them to introduce themselves.
Thanks, Jen. This is John Braman. I'm the Vice President of Strategic Initiatives at Bright Power.
Hi, everyone. My name is Jamie Bemis, and I'm an Account and Market Development Manager at Bright Power. It's a pleasure to be here.
Hi, I'm Joanna. I'm a Senior Sustainability Consultant at Stephen Winter Associates, and I work with our Passive House team there. My colleague, Scott Pusey, also works really hard on this research and can't be here today.
Hi, good morning, everybody. My name is Atalia Howe. I'm the Manager of Sustainability Programs at the Community Preservation Corporation.
And I'm Danielle Donnelly. I'm a Sustainability Associate at CPC.
Great. So what gave us the idea to do a white paper on passive house? High performance buildings is a critical strategy to meet New York City's carbon goals. And passive house is the most obvious strategy of how to make buildings really low carbon. But we found that there's little data out there on whether the energy savings and other benefits of passive house are really realized in multifamily properties. So between Bright Power and Stephen Winter Associates, two of the leading firms working on passive house for multifamily in New York, we realized that we actually had data on a handful of early adopter passive house projects, as well as peer buildings in the city. And that by teaming up with the folks on the phone from HPD and CPC, we could actually start getting information out into the industry that would help lenders, housing agencies, building industry professionals really understand how these passive house multifamily projects are performing. And this is our first effort. In this effort, we focused on understanding the energy performance of these early adopters. We also looked at their carbon emissions and their operational costs in terms of energy. We've begun to look at development costs and non-energy benefits of passive house as well. And our goal in all of this is to really help lenders figure out how to accurately underwrite to these types of projects and help expand their prevalence in the city. So let's talk about the agenda and go through what we're gonna discuss today. So to start off, we're gonna have some kind of technical background on what passive house is all about. Then we'll move on to looking at starting with the energy consumption of 6 early adopter passive house projects compared to typical multifamily buildings in New York. After energy consumption, we'll do a similar comparison of our early adopters to peers based on greenhouse gas emissions, look at the impact under Local Law 97. Then we'll move on to looking at costs and how energy costs at these properties compare to what would be typical budgeted costs in an affordable housing underwriting process in New York City. We'll then lay out a methodology for underwriting to energy savings in these types of projects. And finally, we'll summarize our takeaways and talk about next steps for continuing this research into the future. So let me pass it off to Joanna from Stephen Winter Associates to give us the technical background.
All right. So you may already know about passive house, but let's highlight some of the features that make passive house projects different than a typical building. Passive house can be any type of building. The house is not exclusive to residential, and the goal is to design and perform very efficiently, and it uses a systems approach. Some of the features, as you can see, are an airtight building with continuous insulation, high performance windows and doors, reduced thermal bridges, and that these buildings require inspections and a team approach during design and construction. Another really important feature is that they have controlled filtered air pathways for fresh air coming into the building and another separate pathway for air exiting the building. So we use something called a heat or an energy recovery ventilator to provide this ventilation. And as a result, these buildings require smaller heating and cooling equipment. So they often use a VRF, which is a very variable refrigerant flow. It's a centralized heat pump system that offers heating and cooling, much like a refrigerator that can operate in both directions. So passive house buildings are really impactful to both residents and the communities that they're in. So they're really efficient. They reduce energy and carbon and align with the international and New York City climate goals. They have low operating costs. They are resilient, kind of like a thermos, so residents can shelter in place. They're comfortable. Air tightness and an improved envelope means better thermal comfort and quieter spaces for occupants. And they have a big health impact. There are improvements in air quality over a traditional building, and that's a result of providing an exchange of fresh and filtered air and a separate pathway for exhaust air. All right, so when we're looking at these types of projects, we look at energy models and also reality. So energy models are informed estimates. This is why we want to see how these buildings are truly performing, how the energy model compares to reality. So energy models are useful for evaluating one model against another, but we know reality is different. The goal in a perfect world is to have these aligned. Specifically, we need to look at how multifamily energy model defaults account for a few different things. So there's a lot of behavioral differences. Americans just have different habits than Europeans who wrote the initial passive house standards. These have evolved, but it's still a good thing to really focus in on. I like to think about just our hygiene habits. Do you turn your shower off while you soap up? I don't think so. Another aspect is density. So models utilize certain density counts based on square footage or bedroom counts. How does that differ from real life, especially in dense cities? Another aspect is unit size. We New Yorkers, we know about small apartments, especially now. This density is not universal for apartments across the US. This is a unique factor in New York City multifamily projects. And so, a very granular level of data and monitoring will tell us this. So this is a starting point, and we want to investigate dense multifamily buildings and how they operate. So how do we compare energy use across buildings? So we use something called EUI, which is energy use intensity, and it's a way to compare energy use across different buildings. It looks at annual energy use of a building on a per square foot basis. There are two types. One is source EUI. You can see that in the blue bar, and it's looking at the amount of energy used from the source, from the power plant, to when you flip the light switch on at your home. So it's looking at a much longer impact. Another type is site EUI, and that looks at the amount of energy consumed just on that particular site. And both of these account for different fuel types. So we'll be talking about site EUI when we're analyzing these particular buildings.
Great, thanks for that really helpful background, Joanna. So we're now going to dive into the first piece of results, which is looking at how passive house projects compare to their peers. Quickly to explain kind of our methodology for doing this comparison. The first step was we looked at data that was already available within Bright Power's Energy Scorecards database to identify a set of passive house projects that we already have data on. Now, Bright Power's Energy Scorecards is an online service for tracking energy and water use. So it's important to realize the data that we got wasn't originally captured as part of a study. It was building owners trying to track their performance of their properties. So we actually had to review this data really carefully, make sure it all met the same consistent criteria. And we whittled it down to a set of 4 New York City multifamily passive house projects in our database that met the criteria. Then folks from Stephen Winter Associates contributed data on another 2 passive house projects. So you'll see a set of 6 passive house early adopters that are our kind of key data set for this project. I will say that in our next step, we would really like to expand that data set. We already have about 20 that were tracking in energy scorecards, although they didn't all have the same level of data as these that are included in the study now. Our next step was to create peer groups. And so we also leveraged Bright Power's Energy Scorecards database for this. We looked at 2 peer groups for comparison. The one to pay most attention to are buildings built in 2003 or more recently. Those we think are the right peer set for recently constructed multifamily passive house projects in New York City. And then we have another one for comparison of the older projects that were built before 2003. We looked at projects in both the peer and the passive house projects that had at least a full year of utility data, and we used whatever the most recent year of data that we had available was. Typically, this is parts of 2018 and 2019 to get the most recent full year. We also normalized for weather and for cost when we get to the cost comparison, because we want to make sure that slight differences in the time period that was used aren't screwing up our comparison. Finally, in the greenhouse gas emissions comparison that you'll see, we used actually the same assumptions for emissions factors that are in Local Law 97 in New York for calculating greenhouse gas emissions from our passive house set, so that it's an even comparison to how buildings would be treated under that law. We're really excited to share these results. I'll pass it to Jamie to tell you a bit more about the data in detail.
Great, thanks so much, John. So one of the first steps in setting up our comparisons was establishing our peer groups of conventional buildings that we were going to use as control groups for this study. So at the top left-hand corner of the slide here, you see our base case building group. And for this group, we decided to use buildings in New York City that were constructed using conventional building methods that were built after 2003. And our goal with this was to make sure that we're comparing recently constructed passive house buildings to recently constructed conventional buildings. We didn't want age effects to play into the results. We wanted to make sure that the results we're seeing in this study were the result of high performance design techniques and technologies and not a result of age effects. So in this post-2003 control group, we have 315 buildings from Bright Power's Energy Scorecards database. They're all have 12 months at least of operational data. We decided to use a mix of gas and electrically heated buildings because our passive house groups also have a mix of gas and electrically heated buildings. And we have 315 buildings all built after 2003. Having said that, our team was also really interested to see how our passive house buildings compared to a much broader group of existing buildings. So in the bottom left-hand corner of the slide, you see that we also decided to include a pre-2003 control group of buildings. So this is a much bigger data set. We have 1,633 buildings, again, with 12 months of operational data at a minimum. Again, a mix of gas heat and electric heat. And this is providing a sense for how our passive house properties are comparing to the existing building stock at large. So both of these control groups consist of New York City multifamily housing, and we'll be showing those on all of the results slides in the coming slides. Our passive house case study group consists of 6 buildings. 2 of them are gas heated, 4 of them are electrically heated. You'll note that only 2 of them are certified, whereas 4 of them are built to passive house standards but are not certified. Unfortunately, in this early phase of the study, we were limited by available data. There has been an incredible increase in interest and in the number of passive house projects that are in pre-development and currently in construction. But again, we needed 12 months of operational data in order to include them in this study. And so we were fairly limited. And so the buildings that we have here represent the early adopters, and they represent the first available data for multifamily passive house buildings in the city. So one thing just to note is that we're really excited to see this sample size increase over time, as John mentioned, and look forward to getting more data in the coming months and years as more passive house properties come online. But for now, we've got 6 study buildings and 2 control groups, and you'll start to see our results beginning with energy use intensity on the next slide. So just to get folks oriented, on the far left, you see our pre-2003 building control group. So again, this comes from Bright Power's energy benchmarking database, and we have over 1,600 buildings in this data set. Second from the left, you see the post-2003 conventional buildings. So they are performing a lot better than the older buildings, but you'll see all the green and blue bars to the right are performing even better, and those are our 6 study buildings. So I'll turn it over to Joanna, and she'll interpret this more for us.
All right. So one other note is that these whole building site EUIs are based on building gross square footage, just to compare apples to apples. And these passive house and passive house-like buildings in blue and green bars, they're just outperforming their peers on the left, like Jamie had said. So you can see the site energy for the gas heat is higher than the electric building. Compare this to the passive house target bar on the far right in light blue. To convert the passive house target to site EUI, you have to account for fuel mix and gross square footage, and it's really impossible right now to define one specific passive house target number for all projects, let alone all projects in the study. So this is based on a typical type of building we see, which is 25% gas and 75% electric fuel mix. That's typical of a gas domestic hot water system and electrically heated building. So the certified building targets can be in that low to mid 20s range when properly commissioned. So what is this graph telling us now? The performance is of these passive house and passive house-like buildings in the blue and the green bars are not quite meeting that passive house model target. They're approaching it. So for those of you who've attended this conference for the past several years, we in the passive house community have been anticipating a performance gap, and we need to use actual energy use to identify this gap. So now we have it. So we'll talk a little bit more about what we can do to follow up on this in the future. Like John said earlier during our agenda slide, EUI isn't the only way to evaluate these buildings against their peers. We looked at greenhouse gases, which trap heat in the atmosphere, and they include carbon dioxide mostly, methane, other gases, and they're measured in carbon dioxide equivalents. This is really important in New York City because buildings are responsible for 2/3 of all carbon emissions. And New York City recently enacted Local Law 97 to combat building level greenhouse gas emissions. Each fuel type has a different impact depending on how much emissions it yields. When the grid, the energy grid is all green, the fuel intensity factor will be 0. That's the goal.
Thank you, Joanna. So here we show how the Passive House study group and the pre and post 2003 control group perform in terms of operational greenhouse gas emissions per square foot compared to New York City's Local Law 97 2030 emissions cap, which is shown in light blue to the right. So the greenhouse gas emissions were measured using the 2024-2029 emissions coefficients outlined in Local Law 97 for both gas and electricity. And it's important to note that affordable housing is currently exempt from Local Law 97 caps. However, given the impact that this subset of the building stock has on overall citywide emissions, it's very likely that they will eventually be pulled into the law in some shape or form. As you can see, all of the passive house projects, even those that use gas for heating and domestic hot water, would easily comply with the 2030 emissions caps and are in fact comfortably below the caps. And what this really sums up is that these buildings will not need to invest in measures to reduce their greenhouse gas emissions in order to comply with Local Law 97. Compliance is really built in based on their energy efficient design. So translating these greenhouse gas savings into dollars and cents really helps illustrate the reduced financial risk that these buildings face as a result of carbon regulation. So the chart here shows the greenhouse gas emissions reductions we saw on the last slide translated into avoided penalties or cost savings per square foot. Local Law 97 stipulates that an owner of a covered building that has exceeded its annual building emissions limit shall be liable for a civil penalty of the difference between the building emissions cap for the year and the reported building emissions, multiplied by $268. In other words, to simplify that, $268 per metric ton of carbon dioxide equivalent over the limit. If a citywide carbon trading scheme for greenhouse gas emissions were introduced, and this is currently being explored as part of Local Law 97, and recommendations are expected early next year, there would be an opportunity for buildings to capitalize on their carbon savings. These potential revenues could be significant, which makes this very noteworthy, especially if these savings could be captured in the project's underwriting. Here we show how the Passive House Study Group and the pre and post 2003 buildings in our control group perform in terms of operational greenhouse gas emissions per square foot compared to New York City's Local Law 97 2050 emissions caps, shown in light blue again on the right. Greenhouse gas emissions were measured using the 2024-2029 emissions coefficients for gas, and an emissions factor of 0 was used for electricity. This is predicated on the goals of New York State's Climate Leadership and Community Protection Act, which assert that New York State will have an emissions-free electric grid by 2040. And as you can see here, even when evaluated against this ambitious target set for 2050, all but one of the Passive House projects comply with the cap, and all of the electric heat group projects in green are equal to or below the cap. Again, this chart shows the greenhouse gas emissions reductions we saw on the last slide translated into avoided penalties or cost savings per square foot, illustrating the reduced financial risk for these buildings as a result of carbon regulation. The base case buildings could face steep fines if no work is done to reduce the building's operational carbon emissions, whereas all but one of the passive house buildings are already in compliance. And this really just highlights how future-proof these buildings are, and the way they're designed allows them to never hit the penalty threshold. And just summarizing what we had seen on the last slides, here we show the total avoided penalty for each passive house building and the base case control group based on the building's total gross square footage and the local law 97 penalty of $268 per metric ton of carbon dioxide equivalent. If a carbon trading scheme were introduced in New York City, this would allow building owners to capitalize on their carbon savings, allowing them to sell those savings to building owners whose carbon emissions are in fact above the limit. And as the table shows, these potential revenues really could be quite significant for building owners, ranging from nearly $5,000 to $132,000 per year in 2030. And given the more stringent caps in 2050, these amounts are slightly lower. However, all but one of the passive house projects avoid paying any penalties at all, or would avoid paying any penalties. And on the flip side, the base case buildings could face penalties for being over the cap if they do not pursue low carbon retrofits between now and 2030. And this really highlights the importance of taking a long-term approach when evaluating the full costs and savings of high performance.
Thanks so much, Atalia. Really compelling. And I want to just quickly recap what we've learned so far from this comparison of our early adopter passive house to peer multifamily buildings. Even with this small data set, it's really clear that the passive house projects are performing substantially better than other recently built New York City buildings. On the energy side, we saw EUI energy use reductions ranging from 32% up to 58%. And on the greenhouse gas emissions from 28% up to 62% reductions. And some observations that we want to dig into further in future study are that on the energy side, the passive house certified projects do seem to perform better than non-certified properties that were just still designed to passive house. And also that the electrically heated properties perform much better than the gas heated properties. So insights there that we can keep exploring. In terms of local law 97, the passive house projects, not only do they meet the targets, but if carbon trading is rolled out, which as Atalia mentioned is being actively discussed, they not only would avoid fines, but it could represent a significant revenue opportunity, which I think is particularly compelling for affordable housing that could pursue passive house and get a new revenue stream potentially for that property.
Great, thank you, John. So next we're going to take a deep dive into each of the passive house buildings that we studied in this project. So in this next section, we're going to set aside the control groups that we talked about previously and instead compare the actual performance of each of the 6 passive house study group properties to their expected performance. And from there, we're going to start to understand actual performance versus expected performance instead of earlier we were talking about actual performance versus conventional building actual performance. So I'll explain next how we're going to do that. All right, great. So what you're seeing here on this slide, on the right-hand side, you see the case study building. And this is going to be a cost and weather normalized chart of the actual utility expenses using data from the most recent year. So you see the gas in orange, electric is in blue, and the savings are shown in a light green bar. On the left-hand side, you see the expected performance. And so for this chart, we're using the standard underwriting assumptions provided by HDC and NYCHA. So in order to get the building owner costs, we use the standard HDC underwriting allowances in the M&O standards. And for tenant electric, we used NYCHA standard assumptions. And so what we're going to do here in the next slides is talk about how each of these case study projects compared to what their performance would have been if they were designed and built using conventional methods. And our goal with this study and with this analysis is to understand the cost savings and to then strike up a conversation about if and how we can capture some of those savings in underwriting. So I'm going to turn it over to Jen and she'll talk us through each of these case studies.
So I'm going to walk you through the 6 case studies, the 2 gas heated projects and the 4 electric heated projects. I'm going to spend a little more time on this first one, just so everybody's familiar with how to read these case studies. I think that'll just make it a little bit easier as we walk through all of them. So the first project is a small building completed in 2013 with gas heating. It was not certified as a passive house project, but it was done by a committed team of early adopters who were way ahead of the curve for multifamily passive house in New York City. And even though it's not certified, the overall energy savings are really compelling compared to the baseline. What we're seeing are savings equating to over $40,000 per year. That's pretty significant for a small building. It also means that the building's using less than half of its budgeted energy costs. And if even 50% of these savings were underwritten, the project could leverage from $200,000 to $300,000 of additional debt and reduce the subsidy required to build this. Now, we're using rough calculations to illustrate this, but we think it's useful just to contextualize the idea of underwriting to savings. And before I move on, I want to note a couple things. As Jamie explained, these case studies are sort of abstracted using normalized costs. They're not going to match the utility bills exactly. And also remember, they show whole building energy use, which includes tenant, electric, as well as owner. The next case study is really similar to the previous project, although it was completed 1 year before. And the savings and energy profile is very similar. And again, it's clear there's a lot of additional debt that can be leveraged. Now we're going to talk about 4 projects with electric heating, VRF systems, just to be clear. So this project is a very large and very tall building, also noteworthy in New York City. And while this project is not specifically an affordable housing project, we modeled it that way so that we could compare it to the other case study projects. And you can see that the energy costs are reduced by nearly half, which is more than $300,000 per year in utility savings. Pretty substantial. Also, this project has a lot of studio apartments in it, and they tend to have higher energy use intensities than larger apartments. So that makes this even more compelling. And note also that a really large project like this could potentially unlock more than $2 million in additional debt, also significant. A couple things I want to note for the electric projects. Electric heat is considerably more efficient than gas, but it does have a higher unit cost. Electricity costs more than gas on a per unit basis. So while there are significant energy use and carbon emissions benefits, the costs don't quite keep up with that. So keep that in mind. And also gas has not been completely eliminated on these projects. It's still used primarily for hot water heating. And another thing to note is all of these projects have heat paid by the building owner, and that's relevant to some of you, probably more than others. This next case study, this is a bit of an outlier. It's our only passive house-like project. So not only was this not certified, it was never intended to be certified, but it was built to passive house standards. And we included it because, first of all, we have a limited data set, but also it achieved really significant savings, and it was a useful comparison for the other projects. And you can see, again, it reduced its utility cost by almost 50%. This next project is another mid-sized project, and it was the first passive house project for the developer, although not the entire passive house team. And has a solar array to help offset the electrical cost, which is key for some of these projects with electric heating. One thing I'll say about this project is it did not complete until late 2019, and we only have first-year data on this project. And we know that can sometimes be overly high as building owners learn to kind of manage and commission the systems, but also as tenants get used to using electric heating and controlling their own systems, which is new for a lot of people in New York City. Finally, our last case study, and this one is certainly the most compelling in terms of cost savings. Also, this project really pushed the envelope. That's kind of a bad pun, but it included cogen to supply most of its hot water heating and an extensive solar array across a huge percentage of the roof. The combined annual savings of this project, when you take solar into account, are well over $200,000 a year, which is really great. And in this case, if the project underwrote 50% of these savings, an additional more than $1.5 million could have been leveraged to support the higher incremental cost. And I think somebody said it earlier, it's really challenging to draw conclusions from only 6 projects, but you can see that overall, the case study projects are performing extremely well, especially given that these are the earliest adopters, the pioneers. And the cost savings are really significant, and we've seen that that can really that can unlock additional debt to support the project costs. Now that we know how well these projects are performing, though, what do they cost? And do the cost savings support the additional cost? Let's talk about that a little bit. I'd love to be able to say, and I'm sure you'd love to hear it, that we have accurately determined the incremental cost of Passive House in this study, but I can't. I'm not going to do that. We do think that the 3 to 8% range that New York City experts suggest is really accurate. We've seen that to be true, as well as we could understand that by doing this study. And definitely the experienced teams can produce these projects at the lower end of that range. We also learned a few other things. One, it's extremely difficult to isolate the costs since nobody ever builds the non-passive version of their project. The costs kind of get lost in the noise, and that's because projects in New York City tend to have high costs for a number of factors. And this is exactly what the Pennsylvania Housing Finance Agency discovered when they put Passive House in their QAP in 2017. They saw that of all of the significant number of Passive House projects that were built, some cost more than average and some cost less, just like their pool of conventional buildings. We found the same to be true for HPD's project. Projects can be higher, projects can be lower, and that's true of everything. And certainly, as they say, every project is a snowflake. So what does drive the cost? The biggest hard cost drivers are related to the HVAC systems and high performance windows, and maybe a little bit of padding to account for the unknowns. Design and Passive House certification can also add to the project's soft cost, although less significantly. And there's some evidence that there is additional maintenance costs for the HVAC systems, particularly ventilation and VRF. And that might impact the bottom line a little bit when underwriting Passive House projects. But a few key things to note: the costs are coming down as the learning curve flattens, and also more products become available at lower cost. And finally, incremental costs are highly correlated to the baseline being used for comparison. And this too will change as codes evolve and more people become familiar with Passive House.
So one way we look to cover the incremental cost associated with Passive House construction is to incorporate the utility savings from improved energy performance into the first mortgage. We do that by increasing net operating income. And so net operating income is calculated based on the difference between effective gross income, which takes into account risk factors like vacancy rates, and typical operating expenses represented by the maintenance and operation standards. To increase NOI, you either need to increase gross income by raising rents, or you need to decrease expenses, which are mostly fixed. If we can prove out some measure of cost reduction for certified Passive House and Passive House-like buildings, that gives us a lot of opportunity to not only increase the supportable loan by reducing expenses and increasing NOI, but to potentially decrease the amount of subsidy required from city and state agencies that are committed to investing in comfortable, efficient design for affordable housing. So here we've used the actual annual utility cost from one of the gas-fired Passive House-like buildings to demonstrate the savings potential when compared with the M&O standard and how it affects private debt and subsidy. So if we zoom in to just focus on the utilities, we see that the actual annual utility costs from the Passive House 1A building come out to less than half of the cost projected by the New York City Housing Development Corporation's M&O standard expenses. That means that we have the potential to capture some of that portion of the 56% savings, to leverage additional private debt. These savings provide us the financial leeway to preserve our valuable city and state affordable housing resources by reducing the amount of subsidy needed to finance these projects. And then the last thing to note is that we've incorporated the Local Law 97 trading potential that we explored earlier in the slides as an additional source of income in these buildings. That's the $7,000 that you see on that line. The issue that some lenders face now in underwriting passive house performance is a lack of available and reliable cost data for use as comps. So M&O standards are created using income and expense data from hundreds of existing buildings, and we just don't have data from enough passive house certified and passive house-like buildings to give us the full picture of financial performance. While we continue to study existing stabilized passive house buildings, there are a few ways we can accommodate the risks of more aggressive underwriting and encourage further adoption of these design principles. So one is to understand the project elements and the team's experience and how those factors affect the project outcomes. More experienced teams means stronger timelines, means more reliable results, and that ultimately means less risk for the project. Once you've assessed the team and design elements, that'll help the lender estimate how much of the savings they're willing to incorporate. From there, lenders can calculate NOI using the adjusted expenses that come closer to actual passive house performance, and then determine the additional leverage and new supportable loan amount. Underwriting passive house performance and cost reduction into the first mortgage takes into account the financial stability of the project, but we're not able to fully capture in the first mortgage are the improved property condition, tenant satisfaction, and the reduced operational carbon emissions associated with these design principles. These factors, while not directly calculated and captured in the first mortgage, contribute to overall asset health and the value added by building to passive house standard or by incorporating passive house design principles. So by investing in passive house and high performance affordable housing, we optimize every dollar of public subsidy rather than just maxing out the public investment in getting affordable housing units built.
Thanks, Danielle. That was super informative. Let's recap what we've learned, and I'm sure there's a lot of questions that will come up. Well, we've learned that our case study projects, the early adopters, have significantly outperformed their peers in terms of energy use, energy cost, and emissions, and that the certified passive house and electric heated projects have better outcomes. We've determined the incremental costs are somewhat higher and depend on team experience, the baseline being used for comparison, and the unknowns. And costs are coming down as the learning curve flattens. And thanks to Danielle for pointing this out so well, there are additional non-energy benefits that are important to the health and well-being of our planet and our tenants, and could also be incorporated into underwriting in the future once we can better quantify them.
All right, so lessons learned. We said we'd revisit this. These early adopters, these passive house multifamily pioneers are not at the modeled passive house target, but we're getting there. This is a starting point, and this is really important for the industry. We have some performance data, but we need more information. So what do we need? We need a better understanding of the reality. We need additional monitoring on a more granular level. So we want to know a little bit more about tenant behavior and different types of schedules, what's actually going on in these buildings. Once we have that understanding, it will help the industry identify what end uses can be tweaked to reduce the gap between the actual and the modeled performance. We know this is really challenging, and that it's just challenging to even get utility data to obtain and analyze. So we'll talk a little bit more about that in a moment. And you can see, like Jen said, the PASA certified and electric buildings are performing better. That's pretty important because it's the level of quality assurance and something that projects can aspire to. So the bottom line is we need more data.
So, as everybody has noted, this is only the beginning of the story, and there's a lot more to be done. One of the most exciting things is that a capstone team from City College's sustainability program is working with us on a passive house database for multifamily projects. And it's based on the research we've done so far. It collects all the key data points that we need to expand the research in terms of energy use, cost, and a number of other data points, and ask projects to share performance via the EPA's Portfolio Manager tool, which is free. We do invite all conference participants to add data using the link. It's on the screen, but it's also being broadcast during the during the presentation. And we think this will be a tremendous resource to the entire Passive House community. And do note that we allow data to be shared privately, so no worries on that end. I'm going to turn this over to John to talk a bit more about a few other vectors of study that we hope to engage in.
Great, thanks so much, Jen. And so, yeah, as you can see, we're really excited about the results that we've shared today. Even though it's a small data set, the improved performance of the Passive House early adopters is really clear. But we also think it's the tip of the iceberg, and we're really excited to expand and deepen this research in a couple areas that you can see on the screen. First, we want to do a deeper dive on energy performance. We want to expand the data set. We want to dig in on what's behind these performance improvements that we're seeing, do more targeted comparisons based on properties with similar heating and cooling systems, building envelope design, similar operations. We want to dig in on those questions Joanna raised about modeling and why do the Passive House properties perform differently than their models. There's a lot of exciting stuff to dig into technically, but the second area is to continue to provide research and tools that support lenders on the underwriting side. And that involves looking more closely at the development costs, right? We really want to get a better handle on how New York City development costs with Passive House are changing. We want to tease apart the owner and the tenant parts of the utility cost. Today we presented whole building, we can break those apart. And we're also excited to create this database. You can think of it as a comps database of Passive House properties and how they perform, to put that information at the fingertips of housing agencies and lenders. So again, we think there's a lot of potential, really excited to continue on this research.
Well, it seems like we have a few extra minutes, so we thought it'd be interesting to show you guys a little bit more about the Passive House survey that our capstone team is working on. We really hope that people will be interested in participating. This will, as we said, really advance the cause. It'll expand our database and provide us with all of the kind of information we need to continue to assess multifamily Passive House projects. So a few things about it, and if it's okay, we'll walk through it a little bit just so you can see how easy it is to contribute. So first of all, it's designed to take no more than 10 minutes to complete. We think that's actually accurate. And this comes out of all of the work we've done during the past, it's now nearly a year, of interviewing building owners and talking to the management personnel and so on about their experience in building Passive House, their understanding of the costs as they saw them while they were building the projects, and a lot of other pieces of information that we think are needed to be able to assess the energy data that's in Portfolio Manager. You can't really evaluate that data without understanding the underlying systems, the metering configuration, and it's also good to have context of building size and so on. And feel free, team, to jump in if I'm missing anything. But a few of the, I'll just walk through the survey fields, and I filled them in with really dumb answers. General information, the survey will be geocoded, which will help us assess projects in various climate zones. We'd like to know who's filling it out. What's your role? Have you done a Passive House project before, or who on the team has? What's the project size, number of stories, and so on? Is there commercial space? These are the usual questions that need to be answered to assess Passive House. Were there any incentives or grants? Is the project going to certify? And if so, with which organization? And key, was the project completed? When will it complete? And when is it fully occupied? Again, we need to know that so we can figure out which data to be assessing. A lot of the questions are required, but some are optional. The next page of the survey, we do need to know about the building's mechanical system, whether it's, VRF or hydronic and gas, same with hot water heating, ventilation, and so on. Renewables obviously are important to know. And as I mentioned before, who pays for the utilities, the tenant electricity, the heating, and so on, and how the building is metered. The next page, we really want to get to know a little bit more about the design and construction costs. And as we mentioned in the presentation, knowing what your baseline building is. And we're talking about your baseline. What do you normally build to, so that you can compare what the incremental costs are for your passive house project. And we'd love information as granular as you're willing to give on the hard costs. And we tried to make it really easy to answer, taking the key items we know to drive costs and giving you a range to fill in, so you don't have to go digging into your old project budgets to figure it out. We'd love for some ballpark numbers for soft costs and any information on additional maintenance and replacement costs related to passive house. That is a really important consideration for us and for all passive house financing, and we don't have a lot of data on that. We mentioned before, we'd love for participants to share their utility data through Portfolio Manager. These are free accounts, and that would help us really collect a large amount of data through a standardized source. And then we have a couple of optional questions here. Some of them are about sort of more additional cost details and other lessons learned. A lot of the questions are optional, but we would love to know any other information that you have and are willing to share. The performance page, the performance tab, which I'm on here, we'd love to know how your building's doing relative to your modeled energy use, and specific items. And we noted at the beginning of the chart, before you start, please have your passive house modeling report handy. We'd love to know what your energy model showed. And then some of the qualitative questions, why did you pursue passive house? You as an architect, a building owner, and so on. And what were your challenges? Also, if there's any lessons learned you'd like to share, we'd love to know about that, or frankly, anything else that you think would be interesting or useful in this database. And finally, we'd love to be able to publish some of this information, but of course that's completely voluntary. And please do let us know if it's okay to reach out for additional questions. We're capturing, we think, almost everything we need through the survey, but there's always more things that come up. And would you be willing to have your project featured as a case study in the future? And then contact information, and that's it. As you can see, I went through that in 3 minutes, so I'm sure it won't take you much longer.
Thanks so much, Jen. I just wanted to chime in and emphasize how exciting this survey is as a next step. I remember before I joined Bright Power, I was working at a housing agency, and the refrain always was, we need more data. We need more data. And this is exactly that. And now in my role at Bright Power, where we're looking at energy benchmarking data, we've realized the importance of being able to characterize that data appropriately. And so we need information like mechanical systems and metering configuration and so on and so forth. So I would just say this is really exciting. And I want to reiterate Jen's ask to everyone who's attending, please participate and join us, because this is going to help the industry move forward in a really exciting way.
Right, I'll add to it. Jamie's saying the excitement is here. We think it's really important, especially for first-time passive house project teams, to share their information while the information is fresh in their heads. It's any type of construction or tenant occupant information or any kind of data is important. We've learned a lot just from the interviews with project teams, as well as just taking a step back and looking at the actual numbers. The story is told as a combination, as a layering of all of these items. And growing pains are good. Once you have them, you know how to avoid them, and you never forget them. So that's an important way to share your own growing pain across the industry, and learn lessons from each other.
Just to add from the lending side, while we are really focused on utility bills and wanting accurate utility costs, the experience of the team and the experience of the maintenance and operations teams are also very important to us. How are tenants adjusting? Do you see lower vacancy rates? These are all things that could affect potentially underwriting passive house in the future, and are really important to us, just understanding the whole experience of running a passive house building.
Thanks a lot, Danielle, and I'll put in a final 2 cents. You can see that we're excited by the results we shared today, but we also are really excited to broaden this analysis. So if you're listening, you have a passive house building, or you know someone who's been involved as a developer, consultant, lender, building owner, please fill out our survey, reach out to us. If you're listening and you have funds to help us continue this research, please also connect with us. We're really excited to get started on the next steps. So yeah, thanks to everyone who's been listening today. A big thank you to the conference for having us, and also to our big tent team of Bright Power, Stephen Winter Associates, CPC, and HPD, and many folks on our team in our organizations who've helped with the project so far. But shout out to Jamie and Joanna and Jen and Atalia and Danielle and Scott, and I'm John, who contributed to this first effort. Thanks so much, and have a great day, everyone.